Suppose that a transportation table has been set up like this. We will begin solving this problem by finding the initial solution. To find the initial solution, begin at this square, look at the corresponding supply and demand value, and choose the smallest value. Here, between 300 and 200, the smallest value is 200, so assign 200 to this square. Now, the demand at this column is satisfied and the supply at this row is left with 100 units. Next, we need to move to the next square. We either move to the right or move down. Here, we can no longer move down because the demand value is already satisfied, so we move to the right. At this square, again, look at the supply and demand value and choose the smallest value. Here, between 100 and 400, the smallest value is 100, so assign 100 to this square. Now, the supply at this row is finished and the demand at this column is left with 300 units. And then we need to repeat the process until we reach at the last square and until all supply and demand are satisfied. After we have found the initial solution, we need to proceed to finding the optimal solution. The first thing to do in finding the optimal solution is to calculate R and K. R's are values for the rows, while K's are values for the columns. We need to calculate all R's and K's. R1 must be set equal to 0, and R and K values are calculated by using formula R plus K equals to C, where C is the transportation cost. Please bear in mind that this formula is only applied to U squares, so we need to look only at U squares. For example, at this U square, we have 0 plus K1 equals to 2, so we get K1 equals to 2. At this U square, we have 0 plus K2 equals to 5, so we get K2 equals to 5. Next, here we have R2 plus 5 equals to 3, so we get R2 equals to negative 2. And then here we have R3 plus 5 equals to 8, so we get R3 equals to 3. Finally, here we have 3 plus K3 equals to 3, so we get K3 equals to 0. After we have calculated all R's and K's, the next thing to do is to calculate improvement index. Improvement index is denoted as I and is calculated by using formula I equals to C minus R minus K. Improvement index must be calculated for all unused squares. For example, at this unused square, we have 9 minus 0 minus 0, so we get improvement index equals to 9. At this unused square, we have 7 minus negative 2 minus 2, so we get improvement index equals to 7. Next, here we have 6 minus negative 2 minus 0, so we get improvement index equals to 8. And finally, here we have 4 minus 3 minus 2, so we get improvement index equals to negative 1. Since there exists negative improvement index, the problem is not optimal yet. Now what we need to do is, we need to draw a loop for the square with negative improvement index. To draw the loop, first put plus sign at this square, and then move to the right to this square and make a stop, and put a minus sign at this square. Now from here, move up to this square, make a stop, and put a plus sign. And then move to the left to this square, make a stop, and put a minus sign. Finally, go back to the original square, and we got a loop. Next, look at the loop, look at the squares with minus sign, and look at the values assigned. Choose the smallest value. Here, between 200 and 100, the smallest value is 100, so add 100 to the assigned value at the square with plus sign and subtract 100 from the assigned value at the square with minus sign. There is no assigned value at this square with a plus sign, so we simply put 100 here. Here, the assigned value is 100 and it's a square with a minus sign, so we have 100 minus 100, thus the assigned value vanishes from this square. At this square with a plus sign, add 100 to the assigned value of 100, so it becomes 200. Finally, at this square with a minus sign, we have 200 minus 100, so the assigned value becomes 100. The rest of the assigned values outside the loop maintain their positions. We should actually do this at a new table. So our new table, which is the second table, looks like this. Now that we are at a new table, we need to repeat the whole process all over again, beginning from setting R1 equal to 0 and calculating all R's and K's. Remember that to calculate R and K, we need to use formula R plus K equals to C, which is only applied to U squares. So these are all R's and K's that we got at the second table. And then we proceed to calculating improvement index. And remember that improvement index is calculated by using formula I equals to C minus R minus K, and improvement index must be calculated for all unused squares. So these are the improvement indices for the second table. Here we can see that all improvement indices are positive, therefore it means that we have reached an optimal solution.